This video gives us an introduction to vectors. A quantity that involves magnitude is called a scalar quantity. These quantities are represented by real numbers. A quantity that involves both magnitude and direction is a vector quantity. The magnitude of the vector quantity represents the length of the vector. The direction of the vector, indicated by the arrowhead, represents the direction of the vector quantity. Typical vector quantities are velocity, acceleration, and force. So, for example, the velocity of an aircraft can be represented by an arrow that points in the direction of movement. The length of the arrow represents the speed. Thus, if an aircraft speeds up, we lengthen the arrow. So we see that in those two examples, that the blue arrow representing 300 miles an hour is shorter than the red arrow representing 500 miles an hour. If the aircraft changes directions, we introduce a new arrow in the new direction. And we see that there on the right with the blue arrow starting, and then we change direction, represented by the black arrow. The symbol for a vector is often printed in bold-faced type. So we'll see a lowercase bold-faced V. When writing vectors by hand and we can't boldface, it's customary to use an arrow over the letter or letters. Vectors may be named with either one lowercase or uppercase letter or two uppercase letters. When two letters are used, the first letter indicates the initial point and the second letter indicates the terminal point of the vector. Knowing these points gives the direction of the vector. So for example, vectors OP and PO are not the same vector. They have the same magnitude, but opposite direction. And that's where that two uppercase letter labeling is happening, OP. And if I was handwriting this instead of typing it, I'd put an arrow over each of these, indicating the initial point and the terminal point. The magnitude of vector OP is written like this right here. It kind of looks like absolute value bars, and that makes sense to me because absolute value represents the distance, and the magnitude is the length of the vector or the distance in between the initial and terminal point. It is a fact that two vectors are equal if and only if they have both the same direction and the same magnitude. It's also a fact that equal vectors need not coincide, but they must be parallel on the plane. So typically, these vectors will not be right on top of each other coinciding. They'll just be on the same plane, having the same length and the same direction.